Alright, so today we're going to continue our talk of how to solve equations, and we are going to be solving multiplication and division equations. So much like we did yesterday with the addition and subtraction, we're going to be learning how to solve equations using the division property of equality and the multiplication property of equality as well. Let's get into our first part of vocabulary. So we learned in the last chapter that a coefficient is the numerical factor of a term that contains a variable, and this was on our last test as well, so we know that in the term 3x, 3 is the coefficient. This is important when you're solving equations that need to be solved through the division property of equality, because you need to divide to undo that 3, because that 3 is being multiplied by x. Now, the division property of equality states that if you divide each side of an equation by the same non-zero number, the two sides will remain equal. So in other words, if I know that 16 equals 16, and I divide both sides of this equation by 2, I'll get 8 equals 8, which is a true statement. Okay, so let's get another piece of vocabulary. The multiplication property of equality states that if you multiply each side of an equation by the same non-zero number, the two sides will remain equal. So much like the division property of equality, if I have that 8 equals 8, and I multiply both sides of this equation by 2, I get that 16 equals 16. So once again, we see that just like the addition and the subtraction property, multiplication and division can also be used on both sides of an equation. So let's use this in an example. So the first example is 39 equals 3y, and we want to solve for y. Okay, so in this case, I look at my equation, and I know that I have 39 on the one side, and 3 is being multiplied by y. So the inverse operation that would undo this multiplication would be division. So using the division property of equality, I'm going to divide each side of this equation by 3. I'm going to have 39 divided by 3 is 13. 3 divided by 3 is 1, which leaves me 1y equals 13. Now you could just write your answer as 13 equals y, and you're done. But to check your answer, you're going to want to plug that back in, so we know that was 39 equals to 3 times y. So let's see, what is 3 multiplied by 13? That's 39. So these guys check out. We know we've solved the equation correctly. Okay, let's try another one. At this point, I would think it would be a great idea for you to pause the video and try this one on your own. So we know we've got negative 4z equals 60. So again, the operation that I'm trying to undo by using the inverse in order to isolate my variable is multiplication. So I'm going to divide by negative 4 on each side, because I'm trying to undo this. I get positive 1z is equal to, be careful your sign rules, negative 15. Again, I could just write my answer as z equals negative 15. Again, to check my answer, negative 4 times negative 15, does that equal 60? Indeed it does, so that checks out. Okay? Now, some equations, such as this one, m divided by 2 or over 2 is equal to negative 10, have division already in place, and you need to undo that division. So I know when I see this fraction bar that I'm talking m divided by 2. M over 2 is the same thing as m divided by 2. So in order to undo what's being done to the variable here, or to isolate the variable, I need to multiply. And what am I going to multiply by? I'm going to multiply by 2 on each side. Now, on the left side, since I'm multiplying fractions, it may help me to look at this as 2 over 1 multiplied by m over 2, which gives me 2m divided by 2 equals negative 20. Well, I know that 2 divided by 2 cancels out, leaving me 1m equals negative 20. And that's my final answer. So again, to check my answer, negative 20 over 2, does that equal negative 10? Indeed it does. So my answers are correct, so I check out. Okay? Let's go to our last example before the problem of the day. A over negative 4 equals negative 9. Again, I would say pause at this point and try this one without me. Alright, in order to solve this one, I need to multiply by negative 4 on each side. I know that this and this will cross-reduce, leaving me a over 1, or just a, equals positive 36, because the negative times the negative is going to be 36. Alright, that was our last example. Your problem of the day present you with your problems of the day, technically present you with 4 problems to be done tomorrow, and for you to be ready to put on the board first thing in class. So have a good night, and I'll see you tomorrow.